This is a neat little lesson for all different levels of physics that involves projectile motion. The students would access the lesson from the Moodle website, which looks like this. In this particular case, it's under assignment 1.12. You can see that there's a document called Projectile Lab. The students have laptops at our one-to-one high school, so they would click on that and download it to their computers and work on it locally. The Prelab, which involves homework that would have been assigned for the night before, involves using this PhET simulation from the physics department at the University of Colorado. It involves playing around with this cannon and taking projectile shots here that look like this. And you can change the angle, and the student can change the initial speed of the projectile and its mass, and also the height of the projectile and its physical location on the playing space. So this is a neat way for them to explore projectiles and then answer some of the questions on the assigned sheet. Here are some student results from that particular lab that was assigned. So in this particular case, the student was asked about which specific angles produce the same ranges, and they were able to copy and paste the image from that website simulation here and answer some of those questions, as well as the largest range, etc., etc. Here specifically we see that vectors have been drawn as instructed in the pre-lab. So they're asked to draw velocity vectors. We can see here that the vertical component of velocity is decreasing in magnitude with respect to time. It eventually gets to the top and it's equal to 0, and then it turns around and becomes negative. Whereas the horizontal component of velocity, denoted by this horizontal yellow line, is not changing throughout the motion, showing that it's not accelerated horizontally. This is another way of visualizing the independence of vector components. Further in this assignment, students are asked to place images and draw these vectors in. So they basically copy and paste these arrows to show the direction of the acceleration vector, which is always directed downward and is the same magnitude and therefore the same length. So this is a great opportunity for students to graphically illustrate some of the ideas that we've been discussing in class over the last few weeks. Additionally, they're answering other questions in this pre-lab about the projectile, as well as exploring the effects of air resistance on the motion of that projectile. They do some calculations here, and then eventually move on to the actual meat of the lab, which involves firing a projectile from a vernier projectile launcher and shooting it through a hoop. Now, they only know the initial launch velocity, which is right here. This little object in the video screen is the student shooting the projectile. Their laptop will tell them the initial launch velocity and angle. They have to take this diving ring, which is on a ring stand, and predict where its physical location should be so that the projectile goes through the shot. If I play it here, you'll see that actually happening. Now, this is being filmed at 240 frames per second using a Casio XLM high-speed camera. You can see the projectile is being tracked with the software, and it eventually goes through the hoop. This video, and actually you can see some students celebrating here with their success, and they're clearly pretty excited. This video analysis is done in a software package called Logger Pro. Once they've taken the time to scale the video and determine its coordinate axis, here we can see the XY axis and the origin is at the launch point. We've also can see here with this green line that we've defined what a scale is. That's a known height of about 62 centimeters. We can then do some pretty interesting things here on the graph. Notice as I move the graph, it actually moves and tracks the video in real time. It's a really nice way in physics of connecting a physical event, as seen over here in the video, with a graphical representation, the mathematical, analytical kind of representation of the motion. The student will then answer questions based on this video analysis in that same document. So we can change the axis to show just the x position with respect to time. The students should notice that it's linear. They can determine the slope of that line using a regression tool. This linear fit will give me the slope of that line, and we can determine then the horizontal component of velocity. In this case, it's the slope of the line, or 3.844 meters per second. These kind of modeling tools are built into the Logger Pro software in this particular video analysis. So students are doing a really nice job of using high-speed cameras, in this case much higher than the standard 30 frames per second. That would be difficult to get all of these data points in. This higher speed, 240 frames per second, gives us a very good resolution. The students then take that information, and if we go back to that particular student's document, we can see that she has copied and pasted some of those graphical outputs here. And we can see that she has answered some questions as well based on that motion. It's a very interesting and I think unique way of looking at two-dimensional motion within the context of a physics class.